Hello everyone, welcome back to my channel. Hope everyone is doing great. Let's solve today's Leetcode problem 3346, maximum frequency of an element after performing operations. Okay, we have been given an integer array nums and two integers k and num operations. Okay, we must perform an operation these many times on nums, where in each operation you can choose an index I that was not selected previously in any of its previous operations. Okay, and an integer in the range of minus k to k, add an integer in the range of minus k to k to nums of I. Okay, we have to select an index I such that make sure that it was not selected previously in any of the operations, and we can add any number in the range of minus k to k to that particular number. Okay, after doing, let's say here we have been given two operations. After doing two operations, this array will be transformed into some array, right, some form. In its final form, after performing two operations, we have to return the maximum frequency of the element. Okay, there will be multiple elements and each element will have its own frequency. We have to return the maximum frequency of an element. Okay, so let me jump back to here. Okay, so initially we have been given nums array, right? So we have been given nums array and we have also given k, and let's say n is the length of the array, and we have been given an integer called operations. Okay, at any point of time we can choose a number in the range of minus k to k, and we can also pick an index which was not selected previously. Okay, and then we can add any of these numbers to that particular index. Okay, so for each number, if either we can choose to add minus k or we choose to add plus k, right? So every number will have a specific range in which it falls. Okay, we can choose any number in this range. That means this number can also be transformed into the numbers of a specific range, right? So the first element can be transformed to a numbers which falls in this range. Okay, and the second element can also be transformed into a range of nums of 1 minus k till nums of 1 plus k. Okay, third element can also be transformed to a number which falls in this range, right? So every element can be transformed. Okay, so once we, if you consider all the possible ranges, okay, the overall range will falls between the minimum, which is nums of 0 minus k, and the last one, okay, nums of n minus 1, assuming that our array is sorted. Okay, if it is not sorted, then we have to sort on the ranges. So if our input array, if you have sorted it, obviously the ranges will also be in the sorted order itself, right? So we can take, since the elements are in sorted, okay, the first possible element of my range will be nums of 0 minus k, and the last element will be the last element plus k. Okay, any element if you pick from the input array, and if you are transforming it, it must fall in this range itself. It cannot go beyond this, because that is what has been stated in the problem statement as well. Any number we can add minus k or we can add plus k, right? Yeah. Okay, now we know that this is a possible range in which our numbers can lie. Okay, so we also have an restriction on the number of operations, right? Let's say we want to convert all the numbers to a particular value called num. Okay, that means this particular number, if this has to be transformed into num, that means this num has to fall in this range. Then only you can convert nums of 0 to num, right? Because we can add a number from minus k to k only. This range, if it falls, if a number falls in the particular range, then only this number can be converted into it. Okay, we know that. So we'll pick each and every element on this range and check how many of the elements can be converted into that particular number, and how many operations will it take to convert it. Okay, this is basically the brute force approach which you can actually try. Okay, and you can also keep a variable called answer and identify the maximum frequency as well. Okay, but this would actually fail because the restrictions, if you see, it is 10 power 5 and 10 power 5. Okay, you cannot do order of n square operations. Okay, it must be in terms of n log n, something like that. Okay, so instead of picking each number and identifying what all elements can actually be converted into the particular number, okay, if we can identify the numbers which can be potentially my answer, how can you do it? Okay, since we have sorted this array, okay, we have a benefit that elements in this are in the sorted form. Okay, given a particular number, okay, can I identify what is the minimum? As you know, this number, in order to convert any number to this, either the starting number has to be n minus k, or any number should be n plus k. If any numbers falling in this range can only be converted into nums, right? Because we can add in the range of minus k to k. If we pick any number in this range, then only those numbers can be transformed into num, right? I hope I'm making sense over here. Okay, let me repeat once again. In order to convert any number to nums, we can only pick the numbers in the range of nums minus k to k. Okay, let's say we have picked this number, okay, which you can add a specific value which lies between minus k to k, and then you can eventually land it on the nums, right? So the idea is identify the first element which is actually greater than or equal to k, greater than or equal to k. Okay, any elements which are beyond this, okay, any elements which fall in this area cannot be converted into nums, because we can only add minus k to it or plus k to it, right? So if you choose a number over here, that means you have to add k plus some extra delta in order to fall over here. Okay, similarly, if we cannot choose any number in this range, because if we choose a number over here, in order to convert this into nums, we have to subtract a number which is greater than k. Okay, so since our restriction is to only pick the numbers in this range, the numbers which fall in this range only are my potential solution, correct? Now how can I identify the first number which is actually greater than or equal to this? If we identify, let's say I identified the index at which I have identified the first index. Let's say L is the first index of an element which is greater than or equal to num minus k. Okay, we have identified a first element. I have identified an element whose index is, let's say, L, which is actually greater than or equal to nums of k. Okay, if I know that particular index, and if I also know the index which is less than or equal to nums plus k. Okay, let's say R is the largest index of an element which is less than or equal to nums plus k. Okay, if we identified the element which is equal to nums plus k, that is well and good. Okay, that is one answer. If the input array directly contains nums plus k, then I can directly pick it, or else I have to pick a larger number which is actually closer to nums plus k. Okay, if I have the largest number, only the numbers from this element to this element can be converted into nums. Okay, if we know the length of those elements, if I know the length of this range, only those elements can be potentially converted into my answer. Okay, so how can I find if I have the left and right with me? Okay, let me just put it down here. Okay, yeah, if I have left, right and left, the length of the specific range can be identified with right minus left plus 1. Okay, that means if I have these many elements, okay, I need to perform these many operations to convert into nums, right? Okay, but there is also a restriction that you can only perform nums plus operations, right? Maximum you can perform these many operations. Okay, there is a possibility that this value can turn out to be more than this. Okay, let's say we have a range of 4 elements, whereas we have only two operations to perform. That means we have to only perform two. The rest two numbers, there is no point of converting it, right? So at any point of time, I have to basically take minimum of right minus length plus 1 and the number of operations, right? I hope I'm making sense over here. Okay, let me just remove this. Yeah, so now that you identify for a given okay, number, you can actually convert these many elements into num. Okay, for a given num, you can convert these many elements of the given array into num, right? So there is a possibility that the number which you are the final number to which we want to convert the numbers is actually present in the given array. Let's say we have 2 2 2 2 and 3 comma 4. Okay, and we want to convert the given let's say we want to convert all the elements to 2. Okay, and let's say k is equal to, let's say simply as 1. Okay, so I can actually choose a numbers which are in the range of -1 to 1, right? And that means 0 is also part of this range, right? So adding 0 to this is also a potential answer, adding 0 to this also potential answer, 0 to this, 0 to this, and subtracting 1 from this is also answer. Okay, that means, and let's say number of operations, in this case let's say it is also 1. Okay, that means you have to only perform maximum one operation and get the maximum frequency, right? So if you see, if I just convert this into 2, that will give me my potential answer, right? So even though we have these many 2s, I don't have to convert all of these into my num, which is in this case num is actually 2. Okay, that means either I have to somehow skip these operations on these, or if I add the frequency of num to it, that is also correct answer, right? Either I can choose the minimum of right minus left plus 1, or the number of operations plus the frequency of that number. If I don't have the frequency, okay, then I will basically take it as 0, okay, or else I will take it as 1, or else I will take its original frequency. Okay, so let me jump back to the code and let me show you how I've implemented it. Okay, so we have been, I just initiated n is equal to the length of array and then length of nums, and then I've sorted all the elements, and I also mentioned we need the frequency of each and every number, right? So I just calculated for the given nums, I just calculated what is the frequency of all those numbers. Okay, now that frequency will contain frequency of each and every number, and then I will just initiated answer as 0, which will potentially contain my final answer. And I have mentioned that the range in which my the nums, which the num is a variable, right? This is the variable which we have to pick, right? The potential range is basically nums of 0 minus k till all the way up to this particular value, right? I have to check for each and every num what will be the maximum frequency that I can attain, right? So I have defined num, which is the starting element is nums of 0 minus k, and I will go all the way up to the last element plus k, and I will increment one by one, and I have to identify the first element. As I mentioned, I have to get L and R. L is basically the first index of an element which is greater than or equal to k. Okay, so I just define a utility function called left bound. Okay, here you can simply apply a binary search to actually get the left bound, and also similarly the right bound is basically the first element, the largest element, the largest index of an element which is less than or equal to nums plus k. Okay, that is what I have done here. Okay, now that I have got L and R, so I have to just take the minimum of these two, right? Number of operations plus frequency of the particular num. comma r minus left plus 1. Now that this will tell me the the frequency that I would get by converting all the elements in the nums, all the elements in the original array to num, right? But it's not necessary the first element, converting the first element will give me the answer, or converting the second element, right? I have to get the maximum of all those answers, right? So that is why I'm getting the maximum of all the possible answers, and then I'm returning it. Okay, so this is the algorithm which I've implemented for right bound, and this is the algorithm left bound, and this is the algorithm I've implemented for right bound. Okay, this is pretty straightforward binary search implementation for getting the right bound and left bound. Okay, so let's try to run this algorithm. As you can see, it has passed all the test cases and it is pretty efficient as well. Let's try to analyze the time complexity. Before going into analysis of time complexity, I request all my viewers to kindly subscribe to my coding channel. I've noticed most of the people are not subscribing to my channel, rather consuming my videos. Okay, I highly recommend you to subscribe so that you won't miss the content which I'm posting on daily basis. Okay, so let's jump back to analyzing the time complexity. So sorting will actually take n log n. Time complexity and space complexity would be order of n, right? And I'm assuming that behind the scenes the library we used is basically merge-sort. Okay, and here we are calculating the frequency, so frequency will also take order of n, where n is here n is the total number of unique elements over here. Okay, and this, if you notice this algorithm, okay, we are applying right bound and left bound algorithms on nums, right? So this will, each of this algorithm will take order of log n, where n is the length of the array which is nums, and this particular algorithm will run for all the elements in this range. Okay, let's say m is the range in which we are actually trying to perform this operation, so the overall time complexity will be m log of n. Okay, yeah, so yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. Thank you.